Hello dear students, how are you all? I hope that you are all fine and safe at home. I am Satyamurthy from Bharathidhasanar Matric Secondary School. 1. To find adjoint, first value 1, next to 1 is 0, next again first value 0, again starting value 1 should come. From the third row, so second value is what? 0, cos alpha, first value minus sin alpha. Listen, next starting value 0. From the first row, second value is 0, sin alpha, again first value cos alpha, starting value 0. So once again we need to repeat the first all the values of first row. Listen, 1, 0, 0, 1. Listen, now I am going to find the adjoint directly, very simple. Listen, so in the term adjoint of f of alpha, this is equal to, listen to this, I am going to start from here. So take cross multiply to the first two rows. Listen, first multiply with this and multiply this two element, multiply this two element, and next we need to take cross multiply, that is from this take cross multiply, from this. So again cross multiply, listen, yes, first 1 into cos alpha, that is cos alpha, minus 0 into 0, 0. So cos alpha minus 0. Listen, cos alpha minus 0. First row, first column over. So the second element 0 into sin, what will come? If you multiply with 0, you will get again 0. So 0 into anything? 0. So 0 minus again cos into 0, 0. So 0 minus 0, 0. So in the first row, second column 0 minus 0. So that is again you will get 0. In the last element of first row, listen, 0 into 0, 0. Minus should come while we are taking cross multiply. We should keep minus. Already one minus is there. So minus to minus plus. Listen. So 0 plus sin alpha. 0 plus sin alpha. Listen, from the second row, very simple again. So 0 into sin, what will come? 0. So 0 into cos, 0. 0 minus 0. 0 minus 0. Listen, the second element cos alpha into cos alpha. Cos square alpha. Listen, cos into cos, cos square. So minus should come, minus sign into minus sign. So minus, already one minus is there. So minus and minus plus, sin into sin, sin square. So cos square plus sin square alpha. Cos square alpha, listen to this, cos square alpha plus sin square alpha. So already we know the value, cos square plus sin square equal to 1. Listen, the last element of the second row, minus sin into 0, 0, cos into 0, 0. So 0 minus 0. The last term 0 minus 0. Listen to this. In the third row, so 0 into 0, 0, minus 1 into sin alpha, minus sin alpha, minus sin alpha. Listen, again, so sin into 0, 0, 0 into cos 0. 0 minus 0, again you will get 0 minus 0. Listen, the last element of the third row. So cos alpha into 1 cos alpha. 0 into 0, 0. So cos alpha is the last element of third row. So cos alpha. From this is, we need to transpose. Transpose of this value is adjoint of f of alpha. Listen, now I am going to simplify this. From this, cos alpha minus 0 cos alpha, cos alpha 0 sin alpha, again 0, cos square plus sin square value is 1, 0, the last value minus sin alpha into 0 cos alpha. Now I am going to transpose this value. Transpose this, what will you get? Listen, transpose of this matrix is, so first column changes first row. That is transpose. Listen, column changes rows. Listen, first column I am going to change is first row, cos alpha 0 minus sin alpha. So second column I am going to change is second row. So 0, 1, 0. Third column changes third row. So sin alpha 0 cos alpha. This is adjoint of f of alpha. The left hand side, listen, in the proof, left hand side they are asking f of alpha whole inverse. I am going to find the inverse term, f of alpha whole inverse. This is equal to 1 by determinant of f of alpha into adjoint of f of alpha. Listen, yes. So determinant of f of alpha is what we have find, that is 1. Determinant of f of alpha is 1. So 1 by 1 into adjoint of f of alpha. So this is the adjoint of f of alpha. Listen. So in the left hand side, cos alpha 0 minus sin alpha. The next term 0, 1, 0 sin alpha into 0 cos alpha. So listen to yes. So this is the left hand side, keep 1. Now I am going to find right hand side. Right hand side they given f of minus alpha. Small changes in the given question is f of alpha. The right hand side they given f of minus alpha. I am going to change the alpha as minus alpha. Listen. From the question f of minus alpha. Now we need to change the alpha as minus alpha. Listen, the given question, what they have given in the first row, cos alpha is there. So cos minus alpha should come. Cos alpha already is there. So cos alpha changes minus alpha. The second 0 is there, 0 minus, that is plus. Listen, so sin is there, so sin minus alpha. We need to change only alpha values as minus alpha. So 0, 1, 0. From the third row, minus sin alpha is there, so minus sin into minus alpha. Listen, so 0 cos alpha, cos minus alpha should come. Cos minus alpha. Listen to this. In this term, cos minus alpha, that is in the fourth quadrant. Listen, minus alpha where will come? In the fourth quadrant. In the first quadrant plus theta, the second quadrant 180 minus theta, third quadrant 180 plus theta, the fourth quadrant minus theta. So opposite to the first quadrant. Okay. So cos in the fourth quadrant, cos and secant always have positives. So others will get negative sign. So, minus theta minus alpha in the fourth quadrant. In the fourth quadrant, cos and secant values are positive. So, only sine will get negative. The cos minus alpha, again we will get cos alpha. Listen, from this cos alpha 0, sine minus alpha is minus sine alpha, because in the fourth quadrant sine have negative sign. So, minus sine alpha. Listen, 0, 1, 0. So, already one minus is there. So, sine minus alpha, we will get minus sine alpha, already minus is there. So, minus to minus what will change? It will change as plus. Therefore, plus sine alpha. 0, cos minus alpha equal to cos alpha. So, this is right hand side, f of minus alpha, let us consider true. Now, we check from 1 and 2, from 1 and 2 both are equal, there is no changes. This is 3 by 3 matrix, 3 by 3 matrix. Listen, elements are corresponding elements are same. So, this is equal matrix. So, from 1 and 2, from 1 and 2, f of alpha whole inverse equal to f of minus alpha, hence proved. Question number 4, if A equal to the given 2 by 2 matrix, so in the first row 5, 3, second row minus 1, minus 2, show that A square minus 3A minus 7I which is equal to 0. Hence, find A inverse. So, we need to find the inverse term from the question. First, we need to prove A square minus 3A minus 7I which is equal to 0. To prove this, we need to find A square. Listen, in the solution, first given question A, this is equal to, that is 2 by 2 matrix. In the first row 5, 3, minus 1, minus 2. Listen, I am going to find A square. Listen to yes, A square, this is equal to, so 2 times we need to write the A matrix, that is 5, 3, minus 1, minus 2. Into again, once again write this same, because A into A. So, 5, 3, minus 1, minus 2. Listen, now I am going to take matrix multiplication. So, first row of the, in the first matrix, so operated on first column of the second matrix. Listen, first row operated on first column of the second matrix. Listen, so 5 into 5. So, take cross matrix multiplication, 5 into 5, that is 25, 5 5s are 25, minus 3 into minus 1, minus 3. So, first row first column over. So, first row of the first matrix operated on second column of the second matrix. So, 5 into 3, 5 3s are 15, 3 into minus 2, minus 6. So, first row second column over. So, from the second row of the first matrix operated on first column of the second matrix. Listen, minus 1 into 5, minus 5. Minus 2 into minus 1, minus to minus plus. So, minus 2 into minus 1 plus 2. So, first row, second row operated on second column of the second matrix. Listen, minus 1 into 3, minus 3. Minus 2 into minus 2 plus 4. Now, 25 minus 3, that is 22. 25 minus 3, 22. First row first column element, 15 minus 6 plus 9, minus 5 plus 2 minus 3, minus 3 plus 4 plus 1. Listen, so this is A square. Next 3A. So 3A we can use in direct method. Listen, from the question, A square 3A equal to 3 into A matrix values, what they given? 5, 3, minus 1, minus 2. So, this 3 multiply with every element of this matrix. So, 5 3s are 15, 3 3s are 9, 3 into minus 1 minus 3, 3 into minus 2 minus 6. So, this is 3A matrix. 7I, 7 into identity matrix, 7 into identity matrix, what they given, that is 1 0 0 1. So, multiply within this value 7 0, this 7 multiply with every element of identity matrix 7 0 0 7. So, this is 7I. Listen. From this, from the question, a square minus 3a minus 7I equal to a square value is what? 22, 9, minus 3, 1. So, a square matrix is 22, 9, minus 3, 1. This is a square. Minus 3a, 3a matrix is what? 15, 9, minus 3, minus 6. So, 15 from the first row, 15, 9 from the second row, what is there? Minus 3, minus 6. So, minus 3, minus 6. 7I minus 7I, listen to yes. So, 7I, 7 into identity matrix. So, 7, 0, 0, 7. Listen. So, I am going to subtract now this 2 matrix from the first matrix. 22, first element 22 minus 15 minus 7. So, first row, first column over. The first row, second column element, that is 9, 9 plus 9 plus 9 minus 9 minus 0. So, from the second row, minus 3 minus into minus plus 3 minus 0. So, the second element 1 minus to minus plus 6 minus 7. Listen to yes, plus 22 minus 15 minus 7. What is that? That is minus 22. So, plus 22 minus 22 0. 9 minus 9 0, plus 3 minus 3 0. So, 7, say 1 plus 6 7, 7 minus 7 0. This is 0 matrix is denoted by 0. So, we have proved that a square minus 3a minus 7I equal to 0. From this, from the question, listen, a square, hence we have proved a square minus 3a minus 7I. From this, I am going to take post multiply by a inverse. So, I am going to multiply a inverse with every term of this equation. So, a inverse into a square minus 3 into a inverse into a minus 7 a inverse into I equal to 0. Listen, now a inverse into a square, if base are equal, we can add its power. So, minus 1 plus 2, that is 1. So, a power 1. A inverse a power minus 1 into a square is a power 1. You can write a minus a inverse into a. Listen to yes, always we can write a inverse into a. This is equal to I, identity element, because a inverse, this is power 1. So, if base are equal, we can add its power. So minus 1 plus 1 a power 0. It is denoted by identity matrix. The matrix. Listen, minus 3i minus 7 a inverse into I. If you multiply with anything with identity matrix, you will get same matrix. So a inverse into I equal to a inverse only you will get. From this, minus 7 a inverse equal to 0. From this, I want to find inverse. They are asking to find a inverse. So I am going to keep minus a inverse in the left hand side. Remaining two things taken to right side. Otherwise, keep these two things in the left hand side. Minus 7a taken to right hand side. So if you take this into right hand side, it will change as plus. So plus 7a inverse. Right hand side values a minus 3i. We need to find only a inverse. So a inverse keep in left hand side. If you want to this 7 taken right hand side, it will come in the denominator. So 1 by 7 into a minus 3i. So this is a inverse. Now I am going to apply the a value and the identity matrix value. Listen, 1 by 7 into a matrix is what? What the given matrix? A matrix is 5, 3, minus 1, minus 2. This is a matrix. Minus 3 into I may define identity matrix. So 1, 0, 0, 1. I am going to multiply with 3. You will get 3, 0, 0, 3 from this. Listen to this. So 1 by 7 a inverse equal to 1 by 7 into. Now I am going to simplify this. 5 minus 3. 5 minus 3 is what? 5 minus 3. So first row, first column over. 3 minus 0. 3 minus 0. Minus 1 minus 0. Minus 1 minus 0. So corresponding element subtracted from the first element of the first matrix. Listen, minus 2 minus 3. Minus 2 minus 3. Now we simplify this. So what will we get? 1 by 7 into 5 minus 3 is what? 5 minus 3 is 2. 3 minus 1 minus 5. This is required A inverse. Hence the answer. Dear students, below this video we have attached study material. If you have any doubt, so please go through the study material and self-assessment and 1 mark solutions. So you need to write in separate note. Thank you.